Hey YouTube, welcome to another video. In this episode, I will expand more on gateway static routing with multiple layer 3 switches. In my layer 3 switch video, I have shared how to add a static route from a gateway to a switch to tell the gateway how to reach the VLANs defined at the switch. However, that is between just a single switch to a gateway. In this episode, I will show how gateway static routing makes it easy to have multiple layer 2 switching broadcast domains. I will share the nuances you need to watch out for when setting up multiple layer 2 switches. As can be seen here, this is how my devices are currently connected. I'm using an ER605. It's connected currently to a STMMO PoE switch. This is unmanaged switch, and I'm just using one of the LAN port of the ER605 gateway to connect to the rest of the three layer 2 switches. So for my layer 2 switches, I have an SG2210MP, I have an SG3428X, and I'm using an SG3428 for my third layer 3 switch. So in this diagram, I have three layer 3 switches, each one dedicated to its zone. So the zone doesn't really mean anything in technical terms. It can be a physical location or a virtual grouping like the home lab, living room, or a barn. So without layer 3 switching, inter-VLAN is always going to happen via the gateway. In this example, you can see that I have three VLANs in here. However, since these are not layer 3 switches, any inter-VLAN communication or any inter-VLAN traffic will always have to go to the gateways. So by grouping the VLANs like here in per zone, the traffic can still remain local by using layer 3 switches and defining those localized VLANs. By the way, if you would like to achieve something similar without layer 3 switching, I came up with a similar configuration last year, way back in November and December. So this is the one that I have from November. I have a distribution switch and two access switches. And on December, I only have access switches supporting those layer 2 VLANs. As mentioned during my intro, there are a few things to ensure when implementing multiple layer 3 switches. The first one is to make sure that the gateway and the switch uplink is not using profile all. So this port, and this port. The second thing that you need to watch out for is that make sure each zone switch have a localized trunk profile. So this is going to replace the old profile per layer 3 switch. And because of that, the third and final nuance that I'd like to cover is that access points and access switches connected to the zone's layer 3 switch can only provide the VLANs in that zone. So I have already covered these points in my earlier videos, but it is worth mentioning in here again in case you have not seen it. By the way, in the future episodes, I'll be exploring how to keep all inter-VLAN traffic across independent layer 2 switches within layer 2 switches and use the gateway only for internet access. So having covered that, let me walk through the current configuration and I will also show all those three nuances in the Omada console. So these are the devices that I have. I have the ER605 gateway, SG3428, SG2210MP, and SG3428X as three independent layer 2 switches. So each layer 2 switch have three VLANs defined. For the RT01 SG3428, this is how I have it configured. You can see that I'm not using the profile all for the gateway and switch uplink, and I have VLAN 11, VLAN 21 and VLAN 31 defined, and this is how it is for the VLAN interfaces. I'm not going to open any of the interfaces. If you have seen my layer 3 videos, it should be the same configuration. For RT02 SG2210MP layer 3 switch, this is how it's configured. I have VLAN 41, VLAN 51 and VLAN 61 configured, and these are the VLAN interfaces for RT02 SG2210MP. And last but not the least, the RT03 SG3428X have all these three VLANs defined: VLAN 71, VLAN 81, and VLAN 91. This is how the VLAN interfaces are configured. For the WAN settings, I'm using dual WAN. This is how it's set up. And for the wired networks configuration, I only have one VLAN gateway interface configured, and all the rest are layer 2 broadcast only VLANs. So for the profile, as I mentioned, try to avoid using the profile all as much as possible. And this is the gateway uplink that I'm using as a profile that is connecting the gateway and the switch. And this is how it's configured. And these are the 3 localized trunk profile that replaces the old profile per layer 3 switch. So for the RT01, this is how it's configured. These are the VLANs defined in RT01. So these are the VLANs that I have defined in the trunk profile. Let me just show you for the RT02 and RT03. And for the final configuration walkthrough, you can see that I have 3 gateway static routes. Just to clarify, I want to emphasize that this is not a switch static route. This is a gateway static route. It tells the gateway how to reach the VLANs that are defined in the layer 3 switches. So before the demo, I just want to show my IP address. I'm currently in the admin VLAN 192.168.101.110. So let me do a test ping for the SBIs or switch virtual interfaces. Yes, can be seen here, which is expected. Nothing is replying because I still haven't turned on any of the gateway static routes. So now let me turn on all the gateway static routing. All of them will now reply on my ping, but instead of trying to do a ping, let me show you a trace route instead to show how many routes it takes me from the admin VLAN reaching all of the switch virtual interfaces. So let me pause here for a moment to discuss what happens on the screen. So as you can see, I went to 192.168.101.1, which is the IP address of the gateway. If you're looking at the main screen, my PC is currently here. So it has to go to the gateway before it reaches any of the SBIs or switch virtual interfaces. So the same thing will happen on all the other virtual interfaces. So for my next demonstration, I would like to demonstrate a localized traffic when I'm trace routing any VLANs defined on that particular zone. So I'm going to transfer my cable from the SteamEmo PoE switch to this port of RT01 SG3428, which is currently in VLAN 21. So if you're looking at the main screen, this is my cable. I'm going to remove this and I'm going to transfer it to VLAN 21. So I'm now in VLAN 21. My IP is 192.168.21.5. So let me close this one and let me refresh this. And as you can see here, it's now reflecting I am now in VLAN 21. So once I start doing a trace route for 192.168.11.1, since this VLAN is in this switch, there should only be one hop. There you go, there's only one hop. The same thing can be said for 21 because this VLAN is also defined in this layer T switch. And the same thing will happen for VLAN 31. However, once I do a trace route outside of the VLANs defined in the zone 1 or in this particular layer T switch, like the VLAN 41, then it will need the gateway to route the traffic. And as you can see, I have to go to the gateway to reach VLAN 41. Same thing can be said for VLAN 51 and VLAN 61. So now I'm going to try VLAN 71, which is in RT03 SG3428X layer T switch. We will again use the gateway to reach that VLAN. And there you go. So now I'm going to transfer the cable from RT01 SG3428 port 23 to port 7 of SG2210MP. So if you're looking at the mini screen, and I'm now in VLAN 51 because my IP is 192.168.51.4, and if I do a refresh here, you can see that I am currently in VLAN 51. So let me do another trace route. VLAN 91 is not within the scope of this layer 2 switch. That means I will need to use the ER605 gateway to reach this VLAN. Can be seen here, this is pretty interesting because whenever I'm using SG2210MP as a layer 2 switch, I always notice that when trace routing outside of the VLANs defined in the layer 2 switch, it always uses the default gateway address. So as you can see here, it uses the 51.1, which is the default gateway for my current VLAN for this PC, and then it goes to the ER605 gateway before it hits the other switch. So the same thing will happen for 81 because this is not a localized VLAN. Same thing for 71. However, for this VLAN, VLAN 61, since this VLAN is defined in RT02 SG2210MP, it shouldn't take 3 hops to reach this VLAN. So let's see what happens. There you go. Doesn't even have to get out of the switch to reach that VLAN. Same thing will be expected for this VLAN 51. And same thing for VLAN 41. For VLAN 31, it will use its default gateway in the layer 2 switch. Then it will hit the ER605 gateway before it hits the third switch. Same for 21. And same for 11. So now I'm going to transfer my cable from port 7 of SG2210MP to port 23 of SG3428X to be in VLAN 91. So if you're looking at the main screen, I am now in VLAN 91. My IP is 192.168.91.5. And after refreshing, it can be seen here that I am in this port. And let me do a final trace route for all the VLANs. Again, this is outside of the VLANs defined in this layer 2 switch. This will take at least 2 hops, 1 to the gateway and 1 to the switch. So this same behavior can be seen from VLAN 21 up to VLAN 61. However, for VLAN 71, since this VLAN is defined on this layer 2 switch, there should only be 1 hop. Same thing for 81. If you think about it, it's not really 1 hop because it's just 0 hop. For the sake of trace route, I'm using 1 hop to show what I mean about 1 and then 2. And there you go. So in the future, I'm going to explore that no matter what independent layer 3 switch VLAN you are on, that the hops will be limited to within the layer 3 switches instead of going to the gateway. So I think that's pretty much it for this video. I hope you like this video. I hope you learned something from this video. If you like this video, please give it a like. If you don't like this video, please give it a dislike. But do let me know what you don't like so that I can further improve the video. Thank you for watching my video. I'll see you on the next one. Thank you and bye-bye.